Good morning to you, and welcome to this lecture. Today we have quite a lot of ground to cover, so hopefully we will get everything done with architecture today. And there will be a lot of coding also, I think, so that will be fun and interesting. You had some homework. You were supposed to create a class diagram for the new version of the dice game, and it should look something like this. I did this one in YUML, and that does not support packages, so instead I wrote the package name dot the class name. So it should look something like this. And the interesting part maybe is I will share the screen also. The interesting part is maybe that actually the view is not connected to the model in any way. Because if you remember, we sent in a Boolean and 2 integers. And that was it. So in this case, we actually managed to get the view to be passive, so to speak. No connections to the model whatsoever. And if you remember, we sent in 2 arguments to the play game operation, the view and the dice game. And we used those to play the game and shuffle information between the 2. So something like that. The peer reviews should be done by now, and I think it was quite a good result, just crunching the numbers, and something like 80% of you found the feedback you got to be helpful. 8% did not find it so helpful, and hopefully you at least got 1 that was helpful, and unfortunately like 13% got no feedback, at least not at the deadline. Well, things are like they are in this case. I can't really force anyone to send stuff in, so, well, hopefully you got something. At least you get to look at some other models. So now you have the chance to update your model if you want to, clarify things. For example, if both reviews pointed to something and you don't agree, maybe you should clarify this part so that when you do the final hand-in, everything is as good as possible. I will be posting a new form for the final hand-in. I think the deadline is on Monday at 12. And then we have actually concluded the first workshop assignment. We will start the examination of them, and you will get a result hopefully in a few days. And I will also post my suggested solution to this workshop, so you can take a look at that. That depends on, I have not really looked on how many groups there are. You will definitely get feedback if I don't agree to your model. So, but otherwise you can always compare your model with my model, and I have also written some thoughts about my thinking when I did it. So you should be able to compare at least. Writing good feedback for, like, I don't know how many groups we are, but a lot. Takes a lot of time, so that is a compromise we probably will need to do to get things rolling at least. But if you have questions, you can always ask them, and if you have questions, use Slack, for example, or these lectures. So I think that was a good result. We will check the later ones also, see if they compare to this. So for today then, I could not help myself, but I did actually some more slides. And the first ones are about the model view controller, and we did this last lecture, so I won't be repeating it. Maybe this is a little bit nicer than the one I drew on the smartboard. And you can see here the model package, the view package, and the controller package, and possible dependencies between them. And also, as we said, this relation is optional, and it could also be read-only. And these two relations are often mutually exclusive, so often you decide on one direction here. So either you decide that, okay, we're going to let the controller run things and be dependent on the view, but not the opposite. Or we are going to let the view control things and not be dependent on the controller, but not the opposite. And we have a lot of different names and variations and such. And I actually also posted a paper on the course homepage that could be interesting in this respect. Journey through the land of the model view design patterns. So that paper actually written by one of the professors here at Linnaeus University. So you should definitely take a look at that. If you are interested in the differences between the model view variations here. So, any questions regarding that part? None? So we will actually be diving right into code now, because I'm thinking about a addition to our little dice game. So we will be, maybe we should just go back a little bit here, and there we have it. And this is the latest one that we did. I will just give it a name. And the problem I'm introducing now is that maybe the game is not that fun. We're going to make it a little bit more, at least a little bit more exciting. And I think one of the things that makes this game less fun is that, well, you just press the key and you get the result. The exciting part about the dice game is probably to roll the first die, see the result, and then roll the second one and hope for, oh, I need a 3 now to get the winning score. So we will simulate this rolling of the dice by pausing the game here. So let's just sleep for like 2 seconds here. So we are simulating that, okay, the dice are actually rolled, and it takes a little while for them to show up. So we now have 2 seconds of a pause before we get the result. And this is not exactly what we wanted. We wanted to see the value of the first dice before we got to see the final result. Are you with me? So we would like to see actually that, okay, I rolled a 2, and now I need to hope for a 5. And I got a 5 in this case. So this is not exactly what we want. So how should this be solved? Can you give me any solutions? the dice rolls are already separated. So, well, first we roll the first dice and then the second one, and then we compute the result. Maybe you're meaning something else. So from the controller, we could call roll dice 1, roll dice 2 maybe. But that kind of like also breaks and puts some logic into the user interface that is part of the controller. You don't actually play the game that way. Yes? Yeah, you could put the, you mean you put the pause kind of, but you can't pause and return or get values. So yeah, I probably think we don't want to add logic into the controller. The general idea would be probably to either do like this, and we should of course put that before the sleep. Got a 1 and yay, I got a 6. This is kind of like what we want. But why is this bad? Yeah? Exactly. We just put some view responsibility, user interface into the model. So while this is functional, we can't do that. So this is bad programmer, no coffee. And we have a pattern for this, and in the chat it has already been mentioned that we should use observer callbacks to view. And that is the solution. And another solution would be to send in an object here, a controller object or something like that, but then we get the dependency to the user interface, and we don't want that either. So we need some way of reversing this. Since the model can't be dependent on anything, user interface or something like that, we need some other construct. And the user interface, in this case at least, can't poll also, because, well, we're stuck here. The execution ends, pauses here, and then continues. And fortunately, we have this pattern for this. And it's called observer. And the problem is we want to send a message from one object to another. In this case, we want to send a message from the dice game to something in the user interface. But we don't want a direct coupling between these two objects. Normally when you do this, okay, I send in the object that wants the message as an argument, or I have it as an attribute, and I call functions on that object. But we don't want this in this case, because that would break our architecture. And the solution is to reverse this dependency by letting the sending object, the publisher, the dice game in our case, manage client objects, the subscribers, using an interface. And in this case, the general structure looks something like this. We have the publisher. It has some operations to manage subscribers, add subscriber and remove subscriber. We have some functionality so to notify all the observers, all the subscribers on some kind of event that happens. We define an interface. We call that observer, and we specify the operations that we want to use. And then we can implement different subscribers that handles this event in different ways. For example, playing a sound, for example, printing something on the screen or whatnot. And this way we avoid direct coupling from publisher to subscribers. Rather, we manage a lot of observers in our publisher. So let's try this then. So the first thing we need to do is define an interface. Where should we put this interface? In what little component here? Controller, model, or view? View. So if we take a look at, again, the structure. So this interface would be put in the view. And this is the dice game that resides in the model. What would happen? We would get a dependency, an association in this case, from dice game into something in the view. And that we don't want. So where should we put it? Put it in the controller. Okay, so if we put it in the controller, the observer interface would reside in the controller. The model class would have a association to this package into it. We would have a dependency between the model and the controller. And is that allowed? No. So where should we put it? The model. So I call this interface Dice Game Observer. I define one operation to be implemented. I want to notify when dices are rolled. So I will call that, and I will send the face value that we get. So anyone listening to this will get a notification that, okay, dice was rolled, a face value, I can use this in some way. And that's about it for the interface. And this is actually the hard part in the observer pattern. What should we put here? This is what you need to think about when doing this in your specific case. You get the general solution, you need to apply it in your specific case. And we will add the simple management interface here. I won't be doing the remove this time, and So, okay, after we have rolled the dice, they should be notified. So something like that. Compiles. No idea to run it because we don't have any subscribers yet, so nothing new will happen. And the next decisions we need to make is who should be the subscriber. And in this case, you can choose between either the view or the controller. So either we use this one as an observer or a subscriber and tell it to implement the interface, or we tell the controller to do that. Any ideas of what we should select in this case? Well, if you think back to the first class diagram I showed you, we already could see there that the view had no dependencies to the model. And implementing this interface in the view would add a dependency, an interface realization. And, well, maybe that is not a good thing to do then. If we have managed to keep the view actually passive, maybe we should go for a type that already is dependent on the dice game. And in this case, we already have a dependency in the controller. Or this is the controller. So you could do either one. I think controller in this case is better because we don't add dependencies. And let's just do that then. So, and what should we do here actually? Well, we ought to output the value, I think. That is what we want. So, yeah, let's just do it. So that we know that the things are actually working. So something like that. And the next thing we need to do is tell the game that we are interested in listening to the events. So we add a subscriber and we add ourselves. Now when the die are rolled, first die, we will get a call into this function, and we can write the face value. And when the second die is rolled, we will get a new call, hopefully. First call, second call, and then execution continues here. Cool. Of course, we don't want this, as this is view responsibility. We can't just use the console directly from the controller. So we need to get something using the view. And how should we do that? We don't have a view here. we have a view in this function, but none in this. What? Nothing? Well, we need to put it as a member instead, as an attribute. So we need to move the view from an argument and we can now remove this, and we can do it like that. So now we have at least moved the console stuff into the view using a new function. Maybe we should something like that. So, okay, everything looks fine and dandy. It won't compile because we have made some changes here. The controller needs the view when it starts, and it does not need the view when it runs. So now everything should be working and be architecturally good. Not good. Okay. 6, 1. No. 6, 1. 2. As you see, the game just got really, really exciting now. Maybe. So maybe we should do a little bit more of a cleanup here. This is actually not needed anymore. And we have actually some unused code here. The get dice value stuff is not needed because it's not used. So we should remove that because it's dead code. So we don't want that hanging around. 2, 5. No. 1. Yay! So while being quite a maybe constructed example, you can see how we can use the observer pattern to reverse calling of functions and reverse the dependencies. Instead of a direct dependency, we use an interface and we call objects through that interface when something happens. And this lets us display things in the console while while being inside the game, so to speak. One actually quite cool thing here is that before the view were kind of like knew that how many dices there were in the game. If we wanted to add a new dice, a game with 3 dices, we would have to add functions in the dice game, get dice 3 value or something like that, and we would have to send this into the view, into the display result. So if we would like to add more dices, this would have required changes everywhere. But now we can just actually change the game. And maybe we should do a pause and roll the 3rd dice. And use this dice also, and maybe the new rule is that you should get 9. Build errors. Oh, I forgot to add it. 4, 4, 1. Yay. And this is actually quite neat, because this is exactly what we want. We would like to add changes and do changes in the places where they matter and not have the effects of changes ripple through our whole system. So changes should be, in the ideal case, as locally made as possible. So if I would like to change the game rules, in this case add a new dice, in the optimal case I would just need to have changed the dice game class and not change everything all over. I think this is mostly a fortunate effect in this case. You can't always get away with this. But it actually is a good example of how if you reverse the dependencies, you can do a lot of good things and find a better design, a more stable design. So let's keep that as it is. So a small code run through is asked for. So let's start here in the start of things. We create a new dice game, nothing wonky there. It creates 3 dices and the list. It's empty to start with. We create a console to manage interaction, and we create a view. No, we create a console to display things using the console, and that will be the view, and we do a controller. In this case, we also name the controller after the actor that actually runs it, in this case the player, and we name the function after the scenario we want to play the game. And this is a good thing. And we sent in the view when we created the controller, so we can save that in a member variable. And then we call play game. And maybe the interesting part is in the controller, play game. The first thing we do is add ourselves to the game as a dice game observer, because we want these notifications. Then we display the instructions, and then we ask the view, do you want to play? And we display the instructions again, because this clears the screen and stuff like that. So, well, have some dependencies there maybe. Then we display the game, and we display the result. And when calling this function play, we end up in the dice game here. And we roll the first die. We send the value here. So if we put a breakpoint there, we should be able to step into get value from the dice, and then where did we end up? There. Dice rolled. It calls the view, puts out the face value. I think we should be able to see it now. Maybe this is an old one. Yeah, there we have it. 3. Face value 3. And then this process is repeated for the second die and the third die. Questions? And then we return the result. All right, I will, as usual, post the code for this on GitHub so you can take a look at it. One thing to notice here, do you see any problems with this code? Yeah, exactly. Maybe you paid attention also when I did this. I copy-pasted. Repeated code is not a good thing. What should we do about that? What do you do when you have code that is repeated? Yes? Yeah, you build a method. We take these parts and we look at them. Okay, what do I do here? Well, I roll a dice and then I call all the observers using that dice face value. So this is something that is done over and over. So maybe we should add a function here. And use this instead. And we will just move this code into here, and we will use this. So something like that. So yeah, we also get some suggestion that you could loop the dices, and well, maybe at least if I'm supposed to add more and more dices here, but well, maybe we should use a list of dices or an array of dices or something like that instead. That is absolutely possible to do. In this case, I think this suffices quite good, and well, we lost a lot of code and it became a little bit better. We could add a sleep here also. I don't think it's it makes the game any better because you just have to wait for the first value. So well, we could. I think last year I put the sleep into the dice class also. So we used the observer pattern to solve this problem. And the general structure of the observer looks like this. And as you saw, the hard parts are, of course, okay, what problem do I have? Does this fit? Should I use the observer pattern? How should my solution look? What kind of an interface should I have? What functions should be there? What arguments should be there? Where should I put the interface? Where should I put the classes, what classes should fulfill the interface, and so on. So the work is to find what pattern you need and then apply this pattern in your specific situation. And now we had this model view controller architecture to guide us, and that's not always the case that you have, of course. You could use the observer pattern in lots of different situations. A classical example is this mechanism of notifying in model view controller. But there are, of course, other ideas here. We will do one final thing in the dice game before moving on. And I will probably do this a little bit faster. And to show you, well, make a point, really. Much of the idea of the model view controller is that, OK, we should be able to have multiple user interfaces. That is, well, maybe the key. That is, if we want multiple user interfaces, well, then the model view controller pattern provides that for us. So in this case, I'm just going to make an English version of the console and a Swedish version of the console. So we can take a look at that, how that would look and work. So I add a new class here. Let's just do it like that, and we could just copy everything from here. And paste it into that, and translate. Yeah, I mean multiple user interfaces. This is, of course, something that is not so good because when we say certain words like interface, we sometimes mean different things. We could mean user interface or an interface in the sense of an interface in the code. So I think Matthias here also has a point, and we will get to that point in a while. So we just made the translation, and we would now like the controller to use this one instead. So, well, we change here. We need to change the type, and we need to change this also. So now we should have something in Swedish. No, we did not, because we got a build error. End of file expected. So, okay, in Swedish. 4, 3, 2. And I need to quit, and I need to remember to press the S key this time. So, all right, what happened now? what did I do when I did the Swedish console? Well, I copied almost everything from this one. And if you take a look at it, well, it's really, really obvious that a lot of code is the same. This whole function is the same. This one little one has changed, I think. This one is the same. This one has some new translations. So, exactly, copy-paste. Once more, what should we do then? In this situation, we have duplicated code in two different classes. If we had duplicated code within a class, the standard solution was to look at this code, break it out into an operation, use arguments instead. But what if we have duplicate code in two different types? What do we do? Yeah? Yeah, exactly. We could put the common code, common data, into a more general type and use that instead. So in this case, I think this would be good. So I will actually do the add a new class here, and I will call it ing. So, and we will take the original console class here. So, and we will inherit from and this function, well, maybe not super unique, but at least a little bit unique. So that one we will keep as an abstract function. Maybe just do it like this. This one can be reused as is. This one is unique. This one can be reused, and this one is unique. So, did I mess up now? Yeah, we should keep that one also. This one was unique. This one can be removed. This one can be removed. Because they will be inherited from the abstract base class and used there. And same thing in the English one. Oh, I changed the wrong one. Dang. Let's do it again. This is, of course, the one that should be abstract. This one can be removed, and this one can be removed. So let's compile and see where we have messed up. So do you remember how to do this in C#? Oh, we had 2 display result. Yeah, okay. Yay! Let's quit, and we can actually make another new better changes here. That is that the controller should not be dependent on a concrete type of console view, but rather just something like this. And when we start the program, we can actually just select by creating an English or a Swedish. Is this like second nature to you? Yeah, good. So we can use polymorphism, we can use dynamic overloading, and we can use abstract-based classes to provide reuse of functionality that we have in several different types by creating a new abstract-based class and putting the common stuff into it and overriding the things that we need to override. And this is good, because if we want to add a German console now, we would just get a list of, okay, you need to implement display instructions, you need to implement wants to play, and you need to implement display results, or your code won't compile. And that's a neat thing, to use the compiler to make sure that, well, we have actually managed to implement what we should implement and not forgotten anything. It is not like in PHP, for example, where we just get well, that path wasn't executed, so you don't get any errors from it. Oscar here says that we could use resource files, and yes, in this case, doing this is not so good. You could of course parameterize and use strings as resources, or read them from a file or something like that instead. But this is just an example. And sometimes user interfaces are harder, especially, for example, German. That is like 1.5 times longer than other languages. So that often messes up your user interfaces. So in some cases, you actually need to rework the user interface, even if you just change language. But this is an example. We could do a lot of more things here. We could, for example, this this key here maybe should be put in a variable in this class instead and sent in using the constructor or something like that. And then suddenly we can get rid of this one. So there are still more refactorings we can do here to increase the code quality. But I won't be going into that right now. Questions? None? Sweet. We will be looking at some class diagram for this after the break. So 15 minutes of a break.